Dear friends, in the beginning of this academic year 2020-21, I would like to welcome all of you. You are well aware that Savitribai Phule Pune University has revised your syllabus. You have choice-based credit system syllabus. This year, we are going to study two chemistry papers. Chemistry paper first, physical and analytical chemistry paper, and chemistry second paper, that is CS302, inorganic and organic chemistry. Friends, as far as our chemistry paper second is concerned, we have two sections. First section consists of inorganic chemistry and section second consists of organic chemistry. Organic chemistry section having three topics. We are going to discuss three topics. First topic is aromatic hydrocarbons. Second topic, alkyl and aryl halides. Third topic consists of alcohols, phenols and ethers. Let us consider first topic, aromatic hydrocarbons. Friends, we have studied different organic molecules. What is meant by aromatic hydrocarbons? Aromatic hydrocarbons having a specific property. Aromatic compounds are cyclic one. Second property, aromatic compounds having a certain aroma. And third property, aromatic cyclic compounds having a specific type of bond, double bond. That is alternate double bonds. And fourth important property which obey aromatic compound, that is it obey Haeckel's rule. So what is meant by aromatic compounds? Aromatic compounds, we can define aromatic compounds. Aromatic compounds means benzene and those compounds which resembles in the benzene with certain chemical properties are known as aromatic compounds. So these aromatic compounds can be classified in different ways. Let us consider the classification of aromatic compounds. Classification. Aromatic compounds. Aromatic compounds are classified into two parts. First one, homocyclic aromatic compound. Homocyclic aromatic compound. And second important class of this aromatic compound is nothing but heterocyclic aromatic compounds. What is meant by homocyclic aromatic compound? Homocyclic aromatic compound means these are the cyclic compounds which are made up of only carbon atoms. So these homocyclic aromatic compounds are again divided into different types. First one, monocyclic aromatic compound. The example of monocyclic aromatic compound is nothing but benzene. Benzene is the well-known example of this class, benzene. Second class of this homocyclic aromatic compound is nothing but bicyclic aromatic compounds. Bicyclic aromatic compound means these are the aromatic compound having a two rings fused to each other, and thus the best example of this class is nothing but naphthalene. So this is the bicyclic aromatic compound. And third important class of aromatic homocyclic aromatic compound is nothing but polycyclic aromatic compounds. These are the compounds having a three rings fused to each other, or it may consist of three or more rings. Thus, the best example, well-known example of this compound is nothing but anthracene. So this is the anthracene having a three rings. This is the familiar example of polycyclic aromatic compound. There is also one more compound which is well known to us, that is a phenanthracene. Phenanthracene is slightly different. That is, it is having a structure like this, phenanthracene. So this is the phenanthracene having a. So this is the phenanthracene. Thus, these are the three subtypes of homocyclic aromatic compounds. Let us come to the heterocyclic aromatic compound. What is meant by heterocyclic aromatic compound? These are the aromatic compounds but having a slight difference. In this compound, there is one heteroatom such as a nitrogen, oxygen or sulfur in the ring. So, heterocyclic aromatic compound having again different types, subtypes, and these types are nothing but first type is five-membered heterocyclic compounds. These are the compounds having five-membered ring and having one heteroatom in it. The best example of five-membered heterocyclic is nothing but this is a pyrrole. Pyrrole is a five-membered heterocyclic compound having a nitrogen atom as a heteroatom. So pyrrole. Second one, furan. Furan is a heterocyclic, five-membered heterocyclic compound having a oxygen as a heteroatom. And third, one more compound is there, that is known as a thiophene. And thiophene is nothing but, this is also one five-membered heterocyclic compound having a sulfur as a heteroatom. So first type of heterocyclic aromatic compound is nothing but five-membered heterocycle, and these are the common example found in laboratory. Let us consider second type of heterocyclic compound, that is a six-membered heterocyclic compound. In a six-membered heterocyclic compound, the most common example is pyridine. For example, pyridine. So, pyridine is a six-membered heterocyclic compound having a total six atoms, and one of the atoms is a nitrogen. Nitrogen is heteroatom. So, this is a pyridine. Third type of heterocyclic compound is nothing but bicyclic heterocyclic compounds. And example of this bicyclic heterocyclic compounds are nothing but quinoline. So quinoline is the compound which is made up of two rings having nitrogen as a heteroatom. So this is a quinoline. And second Example of this class is isoquinoline. Isoquinoline is also bicyclic heterocycle, having a nitrogen atom as a heteroatom. But there is a slight difference in quinoline and isoquinoline. Isoquinoline having a nitrogen atom, just change in position of the nitrogen atom. So these two compounds are isomers of each other. Benzenes. So these are some examples of monosubstituted benzene. When one hydrogen of benzene atom is replaced by any other group, we get a monosubstituted benzene. Suppose we replace hydrogen atom of benzene by bromine, then we get a bromobenzene. Bromobenzene. Thus, we can write different derivative, monosubstituted derivative of benzene, that is a chlorobenzene. This is a chlorobenzene. Then, so this is a third is methylbenzene. Methylbenzene. In this way, we can substitute hydrogen atom by substituting nitro group, we get a nitrobenzene. Then in sulfonic acid, if you substitute hydrogen atom by SO3H group, you will get a benzene sulfonic acid. Thus, if one hydrogen atom of benzene is replaced by any group, we get a mono-substituted benzene, and it is the first type of derivative. Let us consider the second type of derivative. We can replace two hydrogen atom of benzene. Consider following example or benzene with two substituents. Suppose this is one derivative having a two substituent on benzene atom. We have replaced first hydrogen atom by chlorine, and again on carbon number 2 there is again replacement of one hydrogen by chlorine. Thus this is the derivative of benzene. It is known as 1,2-dichlorobenzene or ortho-dichlorobenzene. Ortho-dichlorobenzene. By replacement of any two hydrogen of benzene, we have different examples. Suppose this is another example. So what is this? This is nothing but carbon number 1, 2, 3. 3-methyl-chlorobenzene. So this is the example. Again, suppose this is a nitro group on benzene ring, and if we replace fourth hydrogen atom present on carbon number 4, we get this compound that is known as a 4-chloronitrobenzene. 4-chloronitrobenzene. Likewise, we can replace different hydrogen and we get a different derivative. Thus, similarly, we can replace three hydrogen atoms, three substituents. Example of this compound is, suppose this is a NH2, this is aniline, and if we replace second hydrogen by nitro group and fourth hydrogen by nitro group, we get a 2,4-dinitroaniline. So this is the derivative of benzene, 2,4-dinitroaniline. Consider one more example. Suppose this is a toluene. And if we replace second and fourth hydrogen by chlorine atom, we will get a 2,4-dichlorotoluene, 2,4-dichloromethylbenzene. So in this way, one can replace any hydrogen and we get a different derivative. In this way, you can replace more hydrogens, 3 hydrogen, 4 hydrogen, and you will get a different types of derivative. Consider one more example, which is interesting one. So this is a well-known example. What is this? This is a phenol. And if you replace second hydrogen by nitro group, fourth hydrogen by nitro group, and again sixth hydrogen by nitro group, what is this? This is a 2,4,6 trinitrophenol. This is very famous compound, which is also known as a citric acid, and very important compound in organic chemistry. So friends, we have discussed derivative of benzene. In next lecture, we will discuss Hakel's rule. Okay, thank you.